So we've already talked about how to simplify some fractions. Today we're going to talk about how to multiply and divide fractions. And what we're going to realize is that if you know how to multiply fractions, division is just a little extra step beyond that. So let's go ahead and start section 4.3. Now we're going to talk about how to multiply and divide some fractions. Let's talk first on how to multiply some fractions. When we're multiplying fractions, we're going to start with kind of a nice example to illustrate why multiplying fractions is the way it is. For instance, 1/2 times 3/4. Now, some of you might know the answer to this problem if you've ever had multiplication fractions before. You can do this, it's pretty quick. But I want you to know why we do what we do with multiplying fractions. What we're going to do is I'm going to draw a picture of 3/4, and then we're going to think about what 1/2 times 3/4 actually means. So let's draw a picture first of 3/4. If I'm drawing 3/4, how many partitions do I need in my...
4.
What, how many?
4.
Good, because it says the denominator is 4. That means I'm cutting this into 4 segments. And how many do I shade if I'm talking about 3/4?
3.
Would you all agree that this is 3/4?
Yes.
What we're doing, we're going to multiply this by 1/2. What that means is we are going to take half of this fraction. So check out how we can do this visually. If I'm talking about 1/2 times 3/4, I'm going to take half of this whole thing. So basically, I'm going to cut this in half. And I'm only going to keep half of my shaded sections. Into how many partitions did cutting this in half make it? Is it still only 4 partitions?
No.
How many is it?
8.
So when we look at this fraction, we know we have a denominator of 8. How many parts are shaded in now?
3.
Only 3 of them. We took half of our shaded sections. So when we multiply 1/2 times 3/4, or we take 1/2 of the 3/4, we're ending with 3/8. This is why when you look at this thing, what's happening is we're multiplying the numerator times the numerator, that's giving us the 3. The denominator times the denominator, that's giving us the 8. What this does is this cuts this fraction in half again. If we had another number up here, we'd be multiplying that by the 3. So we multiply with fractions, the numerator times the numerator, and the denominator times the denominator. Have you ever seen something like that before with your fractions?
Yeah.
Good. If you have, great. If not, well, this is an introduction for you. So when we multiply fractions, we simply do the numerator times the numerator and the denominator times the denominator, or multiply numerators and multiply the denominators. Some people say we multiply straight across. That's fine to think of it that way. Go straight across our fractions. So this equals 3/8. And what we do is we multiply the numerators and multiply the denominators. Multiply the numerators and multiply the denominators. We go straight across. In general, here's what we do. If we have any two fractions that we're multiplying together, such as, let's say, a over b times c over d. What multiplying fractions says is that we're going to multiply the a times c, whatever those numbers happen to be, over the b times d. We literally just go straight across the numerator times the numerator and the denominator times the denominator. Raise your hand if you feel okay with this so far. Let's try some examples and see how we do this stuff. Let's do 2/3 times 5/7. 2/3 times 5/7, what's the first thing that we're going to do? What do we need to multiply? 2 times what?
5.
And 3 times?
7.
So straight across, here's what we're going to do. I want you to write this step, by the way. I want you to write this out as 2 times 5 over 3 times 7 first. And I'll show you why in about 5 minutes, why we do that step. I can also reinforce this later on when we go through our other concepts, because there's certain things we're going to be able to simplify and certain things we're not. If we write this step, it's going to help us to simplify. So write that step out for you before you do the next one. I know you're probably thinking, well, why can't we just multiply straight across? We will, we are, but this is going to help us simplify as we go. So 2 times 5 gives us how much?
10.
Over? Hey, by the way, since we did simplification, can you simplify that?
No.
We look for common factors, but there's nothing that divides both 10 and 21, so you're done. That's as far as you can go on that. How about 1/3 times 1/9? What are the things we're multiplying here? 1 times, so I'm going to write that 1 times 1 over what now?
3 times 9.
So we do our numerator times our numerator, denominator times our denominator. Then we do that multiplication, and we're going to get what?
127.
Perfect, exactly right. Do you feel okay with our multiplication fractions so far?
Yeah.
So far, good. Let's ramp it up a little bit. So let's do 6/7 times 14 over 27. Now, of course, the first thing that I want to see from you, I want to see this from you. That's the first thing I want to see. I want to see you make that one fraction. Please be doing that. We're learning this stuff in this class. Trust me on this one. Show me that. This is going to help you out not only in this class, but Math A and Math C as well. If you're multiplying fractions, write them as one fraction first. Can you agree to do that for me, please? At least in here, do that. Now, you have a few options on how to accomplish the rest of this problem. Option number 1 is you do what we did over here and just multiply those numbers. If you multiply those numbers, so option 1, we do 6 times 14, we do 7 times 27. What's 6 times 14? Anybody know?
84.
84, okay. Over 7 times 27, did you get that? 100? Sit, I can't hear you. 89. You could get 84 over 189. However, can you simplify 84 over 189? Everybody, yeah?
No.
Yes, absolutely you can. That can be simplified. You certainly can do it. However, that's a pretty big fraction, right? So you might have to use your prime factorization to do that. That might take you some extra time. There are 2 other options you have to simplify this as you go. This is the reason that we write our fractions like this before we start actually multiplying them. Here's why. Option 2 is, instead of actually multiplying the 6 times 14 and the 7 times the 27, instead of doing that, option 2 is you can break this up as you're going. So instead of 6 times 2, I'll think of that as a prime factorization of 2 times 3. Is that still 6?
Yeah.
Times, instead of 14, I'll think of 2 times 7. Does that still represent 6 times 14 to you?
Yes.
You still with me on that? So that's 6, that's still 14, it's still being multiplied together. Now, the 7 times 27, I can think of this as 7 times 27, if you break that up, is 3 times 3 times 3, or 3 times 9. Now I'm going to stick with the prime factorization because that's what I've shown you. Do you agree that this is still 7 times 27?
Yeah.
Okay. Do you see any factors that are the same on the numerator denominator?
7.
7 and 3.
7's the same. What else?
3.
3. Can we cross those out?
Yes.
Yeah, we noticed this. And this is why I have you write this as one fraction. I hope you're paying attention right here. The reason why you write this as one fraction is because you really cannot cross things out until you have one fraction where you have the same factors on the numerator and denominator. A lot of people are under the assumption that you're supposed to cross out right here and right here. That's not actually true, right? The only reason why that works is because I could have written it like this and then simplified. What I want you to do is write that as one fraction before we simplify, because what this does is change the multiplication problem into a simplification problem that you have just finished doing in section 4.2. If we can write this as one fraction, break it up into our factors, then we can simplify stuff out. So when we look at this problem, we look for any common factors that we have. Of course, I'm seeing the 3's. One of the 3's is gone, and you all said the 7's. The 7's are gone. And then I can write this as the product of the numerators, the product of the denominators. What do we have in the numerator here?
4.
4/9.
Yeah, I'll bet you $1 million that if you reduce this one properly, you're going to get 4/9. Which way is easier to do?
What if you just cross-cancel?
I'm giving you a third option. Hang on. You can't cross-cancel.
Oh, I thought that was
Not
all the
yet.
options you could give us.
Well, you just have to wait. Jeez. You're one step ahead of me. But just one. Okay. So, we could do this way. However, it's kind of hard to simplify. We don't want to do that. Well, you have to leave. She had a phone call. That's all. That's kind of funny. Okay, we could do this way, but then you'd have to simplify. That takes a long time.
That would take a long time.
This way, a little bit quicker, right? We break it up, no problem. We cross out factors. This is a good option for you. If you like this option, stick with it. There is one more option I'm going to show you. Option number 3. I'm going to rewrite this because I want everyone to do this no matter what. No matter what. Are you supposed to simplify here? No. I want to see this first. Nod your head if you understand that. I want to see that. So we're going to do 6 times 14. 7 times 27. But here's the last option that you have. We are not going to do something called cross-cancellation in this class. We're going to do something called just simplification. When you write something like this as a product of a numerator and product of denominators on one fraction, we can just simplify like you normally did in your last section. So I do want to see this step. However, we have an even shorter way to do this than this. An even shorter way, and here's what it is. You look for common factors on the numerator and denominator. Those are just numbers that divide something on the top and something on the bottom. For instance, let me give you an example here. If I look at the 7 and the 14, those numbers have something that divides both of them. What number divides both 7 and 14?
7.
So what we do, if you remember this from the very first part of section 4.2, I said you can multiply or you can divide a fraction on both the numerator and denominator by the same number, and it's still equal. It's still the same value. So what we're doing is we're dividing this piece by piece. You with me on this? We're dividing this piece by piece. So I'm looking at this and go, okay, let's divide both 7 and 14 by the same number. What number would that be in this case?
7.
Let's divide by 7. What's 7 divided by 7?
1.
We cross out, we put a 1. You have to continue with the same number though. What's 14 divided by 7?
2.
2.
Okay. Now we're going to look for anything else. I see a 6 and a 27. Do those share a common factor, or do those share something that divides them?
3.
3.
So 3 divides both 6 and 27. We're going to do that piece by piece. How many times does 3 divide 6?
2.
Stick with the same number. How many times does 3 divide 27?
9.
Check for anything else. This is not just a one-time deal. You only do it once. You can check for anything else. We have a 2, a 1, and a 9. Do these share any common factors?
No.
No.
Do I cross out these ones because they're both 2s?
No.
Oh, it's got to be top and bottom. Okay. So if I do the product of what's remaining, I have 2 and 2. What's that give me?
4.
4 over.
9.
I'm going to encourage you to, ultimately, you're going to be using this way. But ultimately, this is the way that people do math, all right? When you go on to A and C, you're doing this. For right now, choose between these two. Don't do this one. Okay, this one's too long. It's too hard. I don't want you multiplying and then having to simplify because you're basically redoing all of this stuff. Okay, that would just be a horrible waste of time. Don't waste your time and give me the multiplication first. If you're multiplying fractions, we can simplify as we go using the second or third method. Raise your hand if you feel all right with that. Good. I'm going to show you both these for about maybe 2 examples, and then I'm just going to show you this one from then on out, okay? Did this make sense to you?
Yeah.
Okay, so we're dividing numbers by the same number. So we're dividing whatever has a common factor, like 7 to 14. 7 divides both those. 7 goes into 7 only 1 time. Cross out, we put a 1. How many times does 7 go into 14? Well, 2 times. We're crossing out, we put in 2. Notice we're just dividing. We're doing 14 divided by 7, that's 2. We're doing 7 divided by 7, that's 1. We're doing 6 divided by 3, that's 2. 27 divided by 3, the same number, that's 9. Let's see if we can pick this up with a few more examples. By the way, you might have heard of a common denominator. Have you ever heard of a common denominator before? If you've had anything to do with fractions, you probably have. Maybe some of you have. Some of you maybe have not. A common denominator would be a denominator that is exactly the same. Is that something we need for multiplying fractions? Did we need the same denominator here?
No.
No. We don't even have to worry about that. That's going to be something a little bit later. So if you're worried about a common denominator, we don't need that for multiplication. We're not going to need it for division. Okay, 6 over 77 times 7/8. Hey, what's the first thing that I'm going to have you do up here? Okay, exactly. I want 1 fraction out of that. Now, if you get really, really lazy, you don't want to write 1 fraction, here's what you can do, okay? If you are multiplying, math people are lazy, I'm lazy. I don't like to show a lot of work either. But you need to show it, especially at this point in your math careers. If you get really lazy, you're like, you know what, I don't want to write the extra step. There's one thing I'll allow you to do. I'm not going to do this on the board. I'll always rewrite it. But if you'd like, you can just do this.
Draw a line.
Yeah. If you are multiplying, does this work for addition? Subtraction? Division? But if you're multiplying and you want to show 1 fraction, just do that. Extend the line, put the dot in the dot. Now that means you're multiplying. That's exactly the same thing that we would have during the next step. You seeing that? Yes, no? You guys with me?
Yeah.
So you can do that if you'd like. Now personally, I'll always rewrite it because I want you to see it step by step. So first thing, I need to see 6 times 7 over 77 times 8. That's the only way that we can simplify fractions, is get them as 1 fraction first. Now there's 2 options. First option is to do what we did here. I don't want you to multiply and get 42 over whatever this is. That's just way too big, right? That would take you a lot of time. We don't want to do that. So option 1 is we could write this out as a product of prime numbers. Instead of 6, we could do 2 times 3. 7 is already a prime number. That would stay there. Instead of 77, we could do 7 times 11. Those are prime numbers. 8 is 2 times 2 times 2. That's 2 to the 3rd power, or 8. And then we can simplify as we go. Are you okay getting down to that far, by the way? 6 is 3 times 2. 77 is 7 times 11. 8 is actually 2 times 2 times 2. That gives you 8. And then we cross out all those factors that are identical.
You always have to do 2 times 2 times 2, or can you do 2 times 1?
You could do 2 times 4 if you wanted to take that little shortcut. What I'm showing you is the prime factorization, so I'm going to go all the way down on that. But really, I mean, if you're going to do the 2 times 4, you may as well just do the cross-out method from there. Right? You may as well just do that. So here we have a couple 2's, no 3's, but we have a couple 7's. We multiply what's remaining.
44.
Yeah, 3 for sure, because we have the 3. 11 times 4 is 44, and that's as simple as it gets. This is what's nice about doing the second and third method here, is once you simplify it, that's it. I mean, there's no possible way you can go any further simplifying, because it would have been taken care of right there. That's what's kind of nice about that method. Now let's try the other way. I'm going to spend a little bit more time on this method because this is the one that you're ultimately going to end up using. What we're doing is we're looking for numbers that divide something on the top, our numerator, and something on the bottom, our denominator. Can you think of any 2 numbers which share that common factor or share a number that divides them?
7.
7 and what? You gotta give me two.
11.
7 and, well, there's no 11, but there's 7 and a 77.
yeah.
But it comes out to 11.
Sure.
That's what she
We can divide both those numbers by the same number. That's what you're looking for. Can you divide two numbers by the same thing? Okay, we got it. We got 7 and 77. What divides both those numbers?
7.
Now you're going to perform the division. We say, how much is 7 divided by 7?
1.
Okay. How much is 77 divided by 7? That's where we're getting that 11.
Yeah.
We keep going until we can't do that anymore. Is there anything else we could do?
Yeah, 2.
Yeah, 6 and 8.
6 and 8 share a factor of
2.
Let's divide by 2, bless you. If we divide 6 by 2, so 6 divided by 2 is?
3.
8 divided by 2 is?
4.
Are we going to get the same thing?
Yes.
Yeah. 3 times 1 is 3. 11 times 4 is 44. We get 3 over 4. Either way we do this, we should end up with the same answer. We have to. It's math. There's only one of them. Okay.
Do we have to do both steps or can we just do
No, just do one. Yeah, I don't want to. I don't want to see both. I'm saying you can choose one. Okay. Right now I'm showing you both, but by all means, please don't do both. I mean, that'd just be a waste of time, right? Certainly don't do all three. My goodness, that's ridiculous. Yeah, this one I don't ever want to see that from you guys. If you show me this, I know that you really don't know how to multiply fractions. Okay. You may be able to multiply numerators and denominators, but you don't know how to simplify it correctly. So I want to see you doing one of these things, but only one of these things. Yeah, good question. We got 23 30-seconds and 4/7. What is the first thing you always do when you're multiplying fractions? Before you simplify, actually.
Make it into 1 fraction.
Yeah, make it 1. If you want to just draw the line, put the dot in the dot, signifying you understand that multiplication is multiplication of numerators and denominators, that's acceptable to me. If you want to do it what I'm going to do, which is 23 times 4, 32 times 7, just write that as another step, that's fine as well. Now, if I were to do this according to the first method, the only thing I would be able to break up on the numerator would be that 4. I could break that as 2 and 2. On the denominator, this is where it gets kind of annoying to do this step. It'd be 2 times 2 times 2 times 2 times 2. That's 5 2's you'd have to write out, right? I don't want to do that. That's why we kind of tend to lean towards this idea, where we just look for numbers where we can divide by a common factor. So let's go ahead and do that. I'm going to skip this method from now on, okay? I'm really just going to show you this one. How many people feel okay with that? Okay, that method is the one you're going to ultimately be using in here and every other class you ever take. So let's go ahead and do that. Can you see a number that divides something on the top and the bottom?
4 and 32.
Okay, 4 and 30. What factor goes into both 4 and 32?
4.
Again, we're thinking of the biggest number, right? Thinking of the biggest number. We don't want 2, because then you have to do this again. We want the biggest ones. So 4 goes into 4, or divides 4 how many times? 4 goes into 32, or divides 32?
8.
Let's look for anything else. Do we have anything else?
Nope.
No. 23, that's a prime number. 7 is a prime number. So we go ahead and multiply the rest of these. 23 times 1. 8 times 7 gives you... That's as good as we can do. It's not simplifiable after that. Question?
So you're multiplying or whatever, you don't have to use a prime number, you just use a number?
Let's say it one more time. I didn't hear you.
You don't have to use a prime number, you just use any number?
When you're simplifying?
Yeah.
Exactly. We can write this as the product of primes if you'd like, but you're going to see that when you do that, if I were to break this up as the product of primes, it's 23 times 2 times 2. 32 is 2 times 2 times 2. 5 2's and a 7. If we're doing that, what we're really doing is we're simplifying just a couple of these 2's, right? That's actually simplifying 4, because 2 times 2 is 4. We're really just dividing by 4. That's what we're doing. We're dividing the top by 4, our numerator, and the denominator by 4, and that's where we're getting that. So we're doing the same process here. It's just we're not having to, or we're neglecting to write out the prime factorization. It is the same idea. It's just you're taking a little, I guess maybe it's not a shortcut really, it's still mathematically legal. You're just dividing the top and the bottom by a larger factor at a time, rather than just 2 at a time. Does that make sense? Okay, so do you need to divide by a prime number? No. Any number that divides both a factor on the top and a factor on the bottom will work just fine. Good question. Let's go ahead and do a few more. Are you getting the hang of this?
Yeah.
4 over 27 times 3/8. And the first thing we do is, what's the first thing we do? Gotta have one fraction. So extend that line, put the dot in the dot if you'd like to, or rewrite it like I'm about to. 4 times 3 over 27 times 8. 4 times 3 over 27 times 8. We're looking for a couple methods here. Either we're going to do this and do the prime factorization, or we're going to divide a number on the top and the number on the bottom by the same number. So let's go ahead and look at this. 4 times 3 and 27 times 8. Someone on the right-hand side of the room, tell me a number that divides, or tell me two numbers that have the same factor.
4, 7.
4 and 8. Okay, here 4 and 8. What number goes into both 4 and 8?
4.
So right now we look at those numbers, we see which one, or which two, have a common factor. We divide by that common factor. So if 4 is the biggest number that divides that, we divide 4 by 4. What's 4 divided by 4?
1.
What's 8 divided by 4?
2.
And right there we've simplified by a factor of 4. We've just divided the numbers on the top by 4 and the numbers on the bottom by 4. Anything else?
3.
Okay. 3 goes into both those. 3 divides 3 how many times?
1.
27?
9.
Make sure you're writing the ones, because if you don't write those ones and you just have this, it looks like there's nothing on the top of that. And if you just are writing 18 afterwards, we're really not having the right idea. There has to be a numerator up there. What is on our numerator? Yeah, really, we have the 1 times 1. That's our fraction, 1/18. Doesn't work with negatives.
Yeah.
Negative 1/4 times 1/2. Nothing about those multiplication rules changed, so a negative times a positive is still a negative. How much?
Negative 1/8.
Negative 1/8. So we would do the negative. We know our answer is negative, and oftentimes it's best to find out the sign of our fraction before we even accomplish the multiplication. Just go, okay, negative times a positive gives me a negative. Think about that first, then start dealing with your fractions. You with me on that? So here we go, okay, we know the fraction is negative. I know it's going to be 1 times 1 over 4 times 2, and that's going to give me negative 1/8. For sure. So it still works with our negatives. Just make sure that we're keeping those signs correct. How about that one? Am I still multiplying?
Yes.
That's what that parenthesis says for us. We're still multiplying. Ladies and gentlemen, do you think I'm going to get a positive fraction or a negative fraction out of this?
Negative.
Sure, positive times a negative is for sure a negative. On our numerator, since we've already taken care of the fact that this is going to be a negative fraction, we can ignore that sign. We already know it's going to be negative. We just put 1 times 11. We put 2 times 28. Does anything simplify in that? 1 times 11, 2 times 28. No, but we should be looking, right? We should be looking for anything that simplifies that. 11's a prime number. 1 is 1. I mean, the only thing that are going to divide those is 1. Nothing else is going to be a shared factor. So we do our multiplication the rest of the way. I know we have a negative. Don't lose that negative. Don't forget about that thing. And then we're just going to have 11 over how much?
56.
Perfect. 11 over 56. Okay, hey everybody, what are we going to have here? A positive or a negative fraction at the end? For sure, why? Okay. So since we know that, you know what we can do? We can just make sure we know that's a positive. Don't put a negative up front. That's fine. We already know our answer is going to be positive. That's what's nice about multiplication and what we're going to find out about division. So on our numerator, what we're going to write is 6 times 26, 13 times 30. And if you're thinking, where'd all those signs go? Well, we already know our answer is positive. That's where those signs went. We know that a negative times a negative is a positive. Now we just have to simplify this thing. So we're writing this as one fraction. Can you see any numbers that divide a number on the top and the bottom? 6 and 30. What number divides both those things?
6.
Sure, so we're going for the biggest number. So we're going to divide both 6 and 30 by the same thing and the biggest thing, or the biggest factor we can find. So 6 and 30 have a common factor of 6. We'll divide 6 by 6 and that will give us
1.
and 30 divided by 6 is
5.
Do you see anything else?
13 and 13.
13, 26. What divides both 13 and 26?
13.
So we'll divide 13 by 13. Oops. That's not right.
Close.
Close. Very close. Yeah, almost. 13 divided by 13 is how much?
1.
So we're dividing here. We're dividing by the number that they share, that is in common. 13 divided by 13 is 1. How much is 26 divided by 13?
2.
We get much quicker than multiplying those things and then simplifying. Much
Negative.
quicker.
Oh, no, positive.
Why is it a positive?
Because it's a negative.
Good. Why don't you try one of these on your own, then we'll start building this up little by little. Hey, our fractions up here, are we going to get a positive or a negative product? What do you think?
Positive.
Cool. So we're going to write this as one fraction first. We'll have 4 times 33. We'll have 11 times 16. We'll start simplifying. I'm looking for some common factors up here. So I'm looking at 11, 33. I know that 11 divides both those numbers. So I'm going to divide each of them by the same number, 11. You have to have the same number here. You can't divide one by one thing and another by another thing. That wouldn't make sense. We have to divide them by the same exact number. That's what's simplifying our factors one by one. So 11 divided by 11 is 1. 33 divided by 11 is 3. Now I'm looking for anything else. I see a 4 and a 16. 4 and 16 share a common factor of
4.
4 divided by 4 is 1. 16 divided by 4 is,
4.
I look for anything else, I've got a 1, a 3, a 1, and a 4. There's no common factors that are shared anymore. I simply have a 3 over 4. That's our answer. How many people got that one? Good for you, that's fantastic. Wait a second. Wait a second, there's more than 2 fractions up there. Can you still do it?
Yeah.
Yeah, you know what? We're going to have the same exact steps. And the very first step, the reason why I have you do this step again, is we can write this, if we can write this as one fraction being multiplied together, we can simplify it. So the first step is write all 3 of these as one fraction. So we say, okay, well this is just 1 times 3 times 25. This is 6 times 10 times 16. Write them as one fraction. That's fine. By the way, I do want to say this. Could you do them, just the first 2,
Yeah.
and then do the next 2?
Yeah.
Absolutely, you can do that too. I'm giving you a quick way. I'm giving you a way to do this all at once. But let's look for some numbers that divide both a factor on the numerator and a factor on the denominator. Can you see 2 numbers which share a common factor? Say that again. 3 and 6. You guys see 3 and 6?
Yeah.
Let's divide. What number goes into both 3 and 6? So 3 divided by 3 is?
1.
6 divided by 3.
2.
Anything else that you see that share a common factor?
5 and 10.
25 and 10. What number goes into both 25 and 10?
5.
How much is 25 divided by 5?
5.
And 10 divided by 5? Do we see anything else? I've got a 1, a 1, a 5, a 2, a 2, and 16. Do those share any factors that divide both the numerator on the top, the number on the top, bottom?
No.
So we're going to go ahead, multiply the rest of it. We have 1 times 1 times 5, that gives me
5.
We have 2 times 2 times 16, that's 4 times 16.
54.
Why did you divide the 10 and 25?
Well, 5 goes into both 25 and 5 goes into 10. So we're saying, what's 25 divided by 5? What's 10 divided by 5? And that's where we're getting those numbers. So we're dividing piece by piece. Little by little, we're dividing those. Okay, I'd like you to try one on your own. By the way, if you would like to do this 2 at a time, you may. We would, of course, write this as one fraction. 3 and the 6 would simplify out. Then we'd have to bring the other one down and simplify from there. So you could do this in 2 steps if you'd like to. There you go.
Is that a 10 or a 16?
The last number?
Yeah.
16. Okay, let's see about this thing. So first thing, you could do this 2 at a time. Here's what I mean by that if you want to see this as an example. You could just write this as Are you with me?
Yeah.
You could just do this as 1 times 2 over 3 times 15, but then nothing simplifies anyway. So you have to add on that other fraction. So we're going to have all these numerators together, all these numerators, denominators together, and then we start simplifying one by one. Do you see any numbers which share a common factor?
3 and 9.
1 and 3, did you make it that far?
Yep.
Then we go 2 and 16.
3 and 15.
Now, here's what I'm talking about. You don't just stop once you make one round of this. You keep going until you have all your common factors eliminated. So here, when I'm looking at 1, 1, and 3, 1, 15, and 8, now I'm noticing that 3 and 15 still share a common factor. 3 goes into 3. 3 also goes into 15. If you got 3 over 120 and you just left it, you don't have this problem right. Okay? Yeah.
You could reduce it.
You can still simplify that. So you cannot stop until you're completely done simplifying. So please, listen to me right now. Don't just do one round and go, oh, I must be simplified. Yay. Yeah, no, totally not. Okay, totally. You can't just do once and then assume you're done. You have to keep going, rechecking your factors until you know for certain that you don't have anything else that divides any of those numbers. Well, we'll find out. Here we have 1, 1, and 3. 3 goes into 3 1 time. 3 goes into 15 5 times. 1 times 1 times 1 is in fact 1. 1 times 5 times 8 is 40. That's your final answer, 1/40. How many will feel pretty good about what we just talked about? Good deal. So what we're learning is that we can multiply fractions simply by multiplying across the numerators and across the denominators and simplifying as we go. Let's see how that applies when we have some variables in there. So 3x over 4 times 8 over 5x. Hey, ladies and gentlemen, last time when we were doing our fractions, what's the first thing that we did before we multiplied, before we simplified, before anything? What did we do? Good, and we're still going to do that. Remember, I let you extend the line if you'd like, or we're going to do what I do and simply write 3x times 8 over 4 times 5x. Hey, quick question. Do I want to, there's only 2 options here, do I want to either multiply this and get 24x over 20x, or should I simplify right now? That's what we're trying to do. So we're trying to simplify as we go. Listen. It really doesn't matter that you have variables up there that are being multiplied. What we're really looking to do is just simplify anytime we have common factors on the numerator and denominator. So we check those numbers and we see if there is 2 numbers, one on the top, one on the bottom, where we have a common factor or something that divides both of them. So when we look at this, do you see any numbers on the numerator and denominator that a certain factor divides?
8 and 4.
Good. Just like last time, even though we have those variables, who cares? We can still simplify the 8 and the 4. What number goes into both 8 and 4, everybody?
4.
Yeah, we're thinking of the biggest number. So 4 divides that. 4 goes into 4 how many times?
Once.
So we're dividing and we're putting the quotient, whatever that is, in place of our number. And 4 goes into 8 how many times?
Twice.
After that, we're going to multiply whatever we have left over. So we have 3x times 2. What's our 3x times 2? Good. And we have 1 times 5x. How much is that?
5x.
You know what, though? We missed something here. I want to show you one more thing. Rachel, you have a question?
Cross out the x.
Oh, yeah, cross over the x.
Yeah. Well, I want you to look at this. Look back at this example over here. You remember when we had a common factor of 4, we divided by 4, we divided by 4? Well, look at that. Do we have anything else that's being multiplied in both the numerator and denominator? The answer is yeah, we do. That does mean 3 times x, right? And that does mean 5 times x whenever we have the same factor. Factor is just something that's being multiplied on the top and the bottom. Whenever we have the same factor, we're just going to simplify that out like we would any other number. So here we simplify our x and our x. And instead of just 5x over 6, or 6x over 5x, we actually get 3 times 2 over 5 times 1, 6/5. So even though we have our x's there, this was really similar to one of the other problems we did. Do you remember this problem on the board when we were simplifying? We had like we had something like that. Do you remember that problem? Yeah. And we wrote this as, oh, this is 6 times 4 times x times x. This was 6 times 1 times x times x times x. Do you remember doing that, folks?
Yeah.
And what we said was, okay, the 6's are gone because they're the same exact number, they're making a 1. And 2 of the x's were gone because we know anything over itself is 1, anything over itself is 1. We would get 4 over x. Are you with me on this, ladies and gentlemen? We're doing exactly the same thing, but here. Notice how we have the x over the x? We're just simplifying as we go, just like we did in that example. Joey?
Would it matter if you have a 1 in front of the x?
Would it matter like this?
Yeah.
We're never going to see it. We're never going to see it. You got to know that 1x really just means x. So it's not incorrect, but it's inappropriate. We never write that 1 in front of there because we know that x means 1x. So whenever you do that, that's fine. Just erase that 1 for me, okay? Let's try a couple more. I'll do one more with you. I'll give you a couple to do on your own, and then we'll continue. All right, ladies and gentlemen, first thing we're doing is what?
Maybe it's 1 fraction.
Let's do that. Either extend the line or rewrite it. We have to do that before we simplify. Hey folks, do you see anything that simplifies here? I want you to notice that by doing this, we actually make a multiplication problem into a simplification problem. We're just now looking for common factors. What do we see that's the same on both the top and the bottom?
3.
Okay, I heard the 2's first, so we'll do the 2's. We're going to divide both of these by 2. What's 2 divided by 2?
1.
And 2 divided by 2 is 1. What else can we do? Even though this is 3y, remember it's really 3 times y. That means we can simplify those 3's.
Yeah.
So 3 divides 3, well, 1 time. 3 divides 3, 1 time. Now let's look real carefully. Can you tell me what's remaining on my numerator?
Y.
Good. 1 times y is just y. How about my denominator?
1.
Now, this is going to be y over 1, but do I have to leave it as y over 1?
No.
How much is y over 1?
Y.
Yeah. Anything divided by 1 gives you that anything back again. So if you ever have anything over 1, I'm just going to make that y. So y over 1, we make that y. I'd like you to try a couple on your own. If you need help, raise your hand. I'll be walking around to help you.
What if it's the other way and it's 1 over y?
Then you definitely have to put the 1,
Okay.
for sure. Try that one. Then try that one. The last one, if you can do the last one appropriately, you really know what you're doing in this. So writing as one fraction first, then simplifying anything we can, looking for common factors on both the top and the bottom. That's what we're doing. Let's see what we get on these things. So we have x squared over y times y cubed over x. First thing I need to see from you is make sure that you're writing this as one fraction. You can only simplify fractions if you have one fraction. That's it. Now, fortunately for multiplication, we know that we can just multiply a numerator times a numerator over a denominator times a denominator. So that's kind of nice. We just put them together, two numerators, two denominators, then we look for anything that we can simplify. Do we have anything? Do we have any common factors that we have up here? If it helps you, if you're having trouble seeing that we have some common factors, do this for me. Do the extra step. Think about it this way. Think about what x squared actually means. What's x squared actually mean?
X times X.
Write it like that. There's no reason why we have to do all of this in our head. Write this as x times x. What's y cubed actually mean?
Y times Y times.
3 times. This is a lot easier to see that, okay, doing this method. Now, unfortunately, if we have like x to the 14th and y to the 21st, yeah, that's going to kind of suck, right? Because you don't want to write out 21 y's. So ultimately, you're going to learn how to use your exponent rules, but we haven't really covered that yet, so we're not going to deal with exponents that are that large. And y times x is on the denominator. Raise your hand if you feel okay doing it this way. Sure, we can write it out. Are there any common factors now? Common factors are shared things that are multiplied. We can cross those out. So x and x, y with a y, just one for one. And we're going to write what we have left over. What do we have on the numerator right now?
X and Y to the second.
Y to the what now?
Second.
Good. Over what?
Nothing.
What's down here?
Nothing.
There is something down there.
1.
1 is down there. Yeah, remember what you're doing here is you're dividing. So when you're crossing stuff out, it's not a 0. It's not a 0 because you can't even divide by 0. It's a 1. So this could be put over 1. There's actually 1 here. Everywhere you cross something out, you're really making a 1 out of that. You're dividing x by x, that's 1. X by x, that's 1. Y by y, that's 1. So you're making 1s out of this thing. Nudge your head if you're still okay. Yeah, okay. So our answer is xy squared. You could have it over 1, but we really don't write the over 1. So it's just xy squared. You so far so good? Now, could you get the same thing by going directly from right here? The answer is yeah. X squared, x to the first power. Notice how this has a power of 1. We don't ever write the 1, but it has a power of 1. If you take 1x away from x squared, you have 1x left. If you take 1y away from y to the third, you have y squared left. That's what we're doing. We're actually subtracting those exponents. So if you like that, do that. That's fine. That's a little step ahead of what this is. Don't worry. If you're not there yet, we'll get there with our exponent rules. It's in a couple chapters, so we'll be there in a while. Now let's look at the next one. Next one, of course, we're going to write this as one fraction first. (6a cubed times 21b over 7b squared times 18a. Do you see anything that we can simplify?
Yeah.
Oh yeah, a lot of numbers we can simplify, and some variables as well. Now, if you like the method going directly from here to here, you could do that here. You have a b to the first power and a b to the second power. We're going to simplify one of those b's. So there's going to be one b remaining. We have an a to the third power, a to the second power. We're going to simplify two of those a's. There's going to be one a remaining. If that's a little bit like, oh, I really don't get that, that's not a problem. Just write out what these things mean, and then it's much easier to see. So I'm going to do one more step for us so we really see what's going on. This is 6 times a to the third. We already dealt with a y to the third. Same idea, a times a. We can always expand that. Times 21b. 21 times b, 21b. all over 7 times, well, b squared is b times b. We have 18, and we have a times a. After you do that, it's kind of a lot easier to see what is going on here. We're canceling out or simplifying out factors over factors. So the same exact thing in the numerator and denominator. So let's go ahead and do our variables first. What do you see simplifies? How many b's?
2. No, 1.
1 b's. 1 b's. Okay. We got this b with one of these b's. Not both of them, just one for one. That's what we're doing here. What are we doing, by the way, when we're crossing out those b's? Are we adding, subtracting, multiplying, or dividing? We're actually dividing. We're dividing both the top and the bottom by the same value. In this case, we're dividing by b. So b divided by b, that's why we're getting the 1. b divided by b, that's why we're getting 1. It's not 0. You're not just eliminating them. You're actually dividing both the top and the bottom by the same number. That's giving you 1 over 1. That's why we can simplify. What else? A's. How many a's?
2.
So let's do this one. Good on our a's. Do we simplify this a?
No.
Can we simplify this b?
No.
So those are going to be remaining in my fraction at the end. Let's do the numbers now. 6, okay, 6 and 18. What goes into both 6 and 18?
6.
6 is great. We want the biggest one. 6 goes into 6 how many
One.
times? Notice how we're getting a 1 just like we got a 1 here. That's the same idea. 6 goes into 18.
3.
Then we have what else?
7.
I know 7 goes into 7 one time. I know 7 goes into 21 3 times. Oh, we're not quite done yet, are we? Because we would have right now a 3 over a 3. Do you guys see the 3 over the 3?
Yeah.
If you were to write this fraction, you would get, here's an a and a 3. Here's a b and a 3. That's the only thing that we have left over besides 1s. We would get 3a over 3b. Can you simplify the 3's?
Yes.
Absolutely. You could have actually done it right here, simplify those 3's. So in either case, we're going to get, that's our answer, a over b. Would you raise your hand and feel okay with these problems? Good, all right, that's fantastic. Let's talk a little bit about exponents. I think I'll end it there, and we'll do division when we come back after the test, okay? Because I want to give you about 20 minutes or so to ask any questions on the test, if you have those. Can we take fractions to an exponent? Oh my gosh, 1/2 to the 5th power? What does the 5th power actually mean?
Times it 5 times.
5 times. So what this really means is 1/2 times 1/2 times 1, 5 times. Now we do know how to multiply some fractions. We get 1/2 5 times. And we know that in order to multiply fractions, even if you have more than 2 of them, what we do is we take numerator times numerator times numerator, all these numerators on one fraction. That's why we did one fraction. 1 times 1 times 1 times 1 times 1 over all the denominators being multiplied. 2 times 2 times 2 times 2 times 2. You guys okay with that so far?
Yeah.
We're basically just multiplying fractions, right? But I want you to think of this. Instead of actually doing the math, I want you to think of what this means. What does 1 times 1 times 1 times 1 times 1 actually mean?
1.
It is 1, but can I write it to some power?
1 to the 5th
1 to
power.
the 5th.
And instead of 2 times 2 times 2 times 2, well, how can I write that?
2 to the 5th.
Here's what I'm trying to show you here. What I'm trying to show you is that this is actually a form of an exponent rule. If you look at this, if you have 1/2 to the 5th power, what that equates to is the numerator to the 5th power and the denominator 2 to the 5th power. So basically, if you have a fraction to the exponent, you just take the top to that exponent over the bottom to that exponent. That's what we showed right here. This is true, right? We did all this work before. So what this means is just take both 1 to the 5th and 2 to the 5th, the numerator to that power and the denominator. What is 1 to the 5th power? How much is that?
1.
How about 2 to the 5th power? That means 2 times 2 times 2 times 2. 32. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this exponent is the same thing as 1/32. So question, do I have to show all this work? Heck no, no, no. All I need you to know is that if you're trying to do an exponent like 2/5 to the 4th, what I need you to understand is that if we're trying to take a fraction to an exponent like this, what that means is we're taking the numerator to that exponent over the denominator to the exponent. So you don't need to show me this. Just show me that you know that I'm going to do 2 to the 4th over 5 to the 4th. Because of this reason, I'm just multiplying that fraction over and over again. So all the numerators are multiplied that many times, all the denominators will be multiplied that many times. How about it? What is 2 to the 4th? Do you know? How much? 16. Yeah. How's she getting 16?
2 times 2 is 4.
How about 5 to the 4th? Oh my gosh. Have you figured out 5 to the 4th? What's 5 to the 4th mean? Does it mean 20?
No.
No. It means 5 times 5 times 5 times 5.
675.
Say it again?
625.
625, yeah. 5 times 5 is 25. Another 5 times 5 is 25. 25 times 25 is 625. You do it that way. You can do 125 times 5. It also gives you 625. And you're done. The nice thing about this, I'll show you something kind of cool. Nice thing about this is that you know for sure that this fraction cannot be simplified. And here's how you know that. If this could be simplified, this one would have been simplifiable. Can you simplify 2/5?
No.
So notice what you're doing. You're just writing more factors of the same numbers. None of those factors are going to cross over if they didn't cross over here. So if you have no common factors here, when you multiply more and more of them, you still have no common factors. So if this one can be if this one cannot be simplified, this one cannot be simplified either. That's kind of nice, right?
So if you get a question that says like 4/10 to the 4th power,
Simplify it first.
simplify it first.
Sure. Why don't you try this one? Let's do 3/4 to the 3rd, and then we'll look at what it means to have negative 4/5 to the 2nd. So 3/4 to the 3rd power. What this really does mean is 3/4 times 3/4 times 3/4, 3 times. Or we can think of it, which is probably a quicker way to do it, we can think of it as simply, so we can mute that. Nope. We can think of it as simply 3 to the 3rd over 4 to the 3rd. As long as you're taking both the numerator and denominator to the same power, that's what we're doing here. How much is 3 to the 3rd power?
27.
Good. We can't just put 9. Okay, don't get caught in that trap of just saying, oh, 3 times 3, that's 9. Yay! No, what we're really doing is 3 times 3 times 3. That's what that means. And this is certainly not 12. We're not just doing 4 times 3. We're doing 4 times 4 times 4. How much is that?
64.
Yeah. Can you see that with these exponents, your numbers grow really, really, really fast. I mean, if you did 4 to the 4th power, you'd have 64 times 4 again. Wow, you're getting something like 256. I mean, that's pretty large already. So they keep growing very, very, very fast. Now, how about this one? Negative 4/5 to the 2nd power. What does that actually mean?
Negative 4 times negative 4.
Negative 4/5 times negative 4/5. Yeah. Hey, what's a negative times a negative?
Positive.
Tell me something then. What's going to happen every time you square a number, no matter whether it's fraction or not?
Positive.
No matter what. If you take a positive times itself, you are going to get a positive, right? If you take a negative times itself, a negative times a negative, that also gives you a positive. So we know automatically, if we have a negative inside of our parentheses and we're squaring that, our answer is going to be positive. It's very useful to find out the sign of your answer before you actually do the math. So we know we're going to get a positive. Now we just have to do 4 squared over 5 squared. Where'd the negative go? Well, we know our answer is going to be positive. How much is 4 squared, folks?
16.
Over
25.
as much as you can do. How many people feel okay with these exponents? That idea. Good, all right. Would you like to do division now or later?
Later.
Of course, procrastinating. So we're continuing on with some multiplication and division of fractions. And what we learned last time is that if we have some fractions, we can certainly multiply them. We have really 3 options to multiply. We multiply fractions straight across, but we really do want to continue to simplify these things as we multiply them. So for instance, if we have something like 7 over 38 times 2 over 21. Times 2 over 21. I'm going to start asking you this question. Do you need what's called a common denominator to multiply fractions? What that means is you need the same number on the bottom of your fractions to multiply them. The answer is no. And we're not going to need it for division. However, when we get into addition and subtraction, I'm previewing some information here, we will need one. And we'll talk about that towards the end of our day today. So in our case right here, we have 7/38 times 2/22. What's the first thing we're going to do when we start multiplying our fractions?
Put in one fraction.
Good. So before we actually start simplifying, I want to see one fraction. I let you do one thing. I let you extend this line and put the dot. You remember doing that?
Yeah.
This is from before our test. Or you can rewrite this as 7 times 2 over 38 times 21. Now, the next part, you really do have options. There's 2 choices for you. I'm going to show you the second choice. The first choice is you prime factorize each one of these numbers, do the prime factorization, and simplify common factors on the numerator denominator. The other thing that you do is you understand that you can divide both the numerator and denominator of a fraction by the same number, and it remains the same value. It's an equivalent fraction. So we would look at this 7, 2, 38, 21. We try to see if there are any numbers that divide both a number on the numerator and a number on the denominator. So we're looking for this. I'm seeing 2 and 38. I know that a number divides both 2 and 38. What number is that? 2 divides that. So we're going to divide both 2 and 38 by the same number, 2, and we'll write the quotient, the result of that, in place of those numbers. So right here we'll divide 2 by 2. What's 2 divided by 2? So we cross out that 2, we put a 1. We cross out the 38, we divide 38 by 2, and we get how much? 19. Next up, we'll look for any other numbers that we might have. Is there anything else that we have here?
7.
What number divides both those?
7.
So we'll divide by 7. We divide 7 by 7, we get 1. We divide 21 by 7, we get 3. Hey, is there anything else that we can divide? We've got 2 1s, we've got a 19, we've got a 3. Anything else have common factors there? That's what we're looking for, is common factors. So we multiply what's left over. Can you tell me what's going to be on the numerator?
1.
How do you get 1?
1 times 1.
Okay. And on the denominator, we'll multiply 19 times 3. That is how much? Good. Can you simplify 1 over 57?
No.
In fact, if you do this properly, you'll never have to simplify that fraction. It should all be taken care of right here. Now, a lot of people on their simplification got to the very end, this is the last couple problems of your test, and only did one step of simplification. If you can still simplify, you should do it, okay? Make sure you go completely down to the very end where you don't simplify anymore. How many feel okay with this multiplication? Good, all right. Now, we're ready to talk about division. We've already talked about exponents. Let's move on to division. Before we talk about division, I've got to give you a new word. The new word I'm going to give you is called a reciprocal. Can you guys say reciprocal with me? Good, reciprocal, that's right.
So that problem is not division?
This is not division. This is multiplication. Reciprocal. Okay, what in the world is a reciprocal? Here's what a reciprocal is. A reciprocal in terms of math, deals with these fractions. We're dealing with fractions, okay. A reciprocal takes a fraction and it simply, if you ever heard of a reciprocal, you know what this means, takes a fraction and it flips it upside down. That's called reciprocating or finding the reciprocal of a fraction. So if I asked you to find the reciprocal or to reciprocate a fraction, what you do is you would take your fraction and write it upside down. Does that make sense to you? So instead of 1 over 57, we would have 57 over 1. That's all a reciprocal is. That's this new word for us. So a reciprocal, to find the reciprocal of a fraction, I'm going to say this way, it's not very mathematical, but I don't want to say you write the numerator in the denominator's place and the denominator in the numerator's place. I'm just going to say you can flip it over. You flip that fraction over. So to find the reciprocal of a fraction, you're going to flip the fraction. So the numerator becomes the denominator becomes the numerator. Okay, let's try several examples here. First off, let's do the fraction is 2/5, and we're going to be looking for the reciprocal. The reciprocal just says you're taking that fraction, I want you to flip it over. So the numerator now becomes the denominator, and the denominator becomes the numerator. Can you tell me instead of 2 over 5, what am I going to have as the reciprocal? Perfect. How about, let's see, how about 1/5? Can you tell me what's the reciprocal of 1/5, ladies and gentlemen? Okay. Hey, when you do this and you get 5 over 1, how much is 5 over 1?
5.
So if you take the reciprocal of 1/5, you could actually get a whole number out of that. Well, what that suggests is that if I have a whole number, can I find the reciprocal? For instance, if I have 7, can I find the reciprocal of 7?
1 over 7.
Well, this is like 7 over 1, right?
1 over 7.
Good. So the reciprocal of 7 is 1/7. You can say that you've written this as 7 over 1, change it into a fraction, then you reciprocate that fraction, you get 7 over 1. Rich, how do you feel all right with this so far? Okay, one more I did want to show you. Let's say that we had negative 3/4. What's the reciprocal of negative 3/4? What was that? Negative 4. So do I change the sign of my fraction when I flip it over? If I'm just reciprocating? No. So if I have a negative 3/4, the reciprocal is a negative still. It's negative 4/3. I just wanted you to see that that negative doesn't change at all. We're simply flipping that fraction over. Now, why in the world are we doing all this stuff? Why are we dealing with this reciprocal idea? Well, here's the deal. I'm going to lead you to what division of fractions really is. I want you to consider these two problems. Six divided by 2 and 6 times 1/2. I want you to look at those two problems. They're very basic problems. We can do these things in our head probably. Can you tell me what is 6 divided by 2? Okay. Now, Also, what's 6 times 1/2? I'll do this below there. 6 times 1/2, 6 as a fraction is how much?
Over 1.
So this is the same thing as 6 over 1 times 1 over 2, right? Yes, no? And to multiply fractions, I know I would write that as 1 fraction first, put my dot dot, and then I would simplify. What goes into those numbers? 2 goes, okay. This would be 1, this would be 3. What's my answer going to be?
3.
Okay, 3. Yeah, I would say definitely get 3 over 1, or in other words, just 3. Okay, now we're stop here. Do you guys agree that 6 divided by 2 is 3, and also 6 times 1/2 is also 3? Raise your hand if you feel all right with this so far. Here's the whole. What we know is that if we have 6, the same number here, and we do an operation here and an operation here, and it gives us the same exact number, what this says to us in math is that this operation and this operation must be exactly the same, because it gave us the same exact answer. It must be the same thing in this case. And that's true. What I want you to do is consider the relationship between the number 2 and the number 1/2. What are those things that we just learned? What are those? How do you get from 2 to 1/2, or from 1/2 to 2?
Reciprocal.
Say that louder, Jeff.
The reciprocal.
Do you guys see that they are reciprocals? If you reciprocated 2, you're going to get 1/2, right? If you reciprocate 1/2, flip that over, you're going to get 2 over 1 or 2. Not sure if you're with me, folks. Okay. Here's what this says. It says instead of actually, now this way probably seems harder to us because we're using a fraction, but keep in mind that I'm not always going to have a whole number here. I might have a fraction. This is what this says. It says instead of dividing by a number, I can actually multiply by the reciprocal of that number, and it will give me the same answer. Instead of dividing by a number, I can multiply by the reciprocal of that number, and it will give me the same exact thing. You with me on this? I just showed it. It says instead of dividing, we could actually multiply by reciprocal, and that's exactly how we accomplish the division of fractions. Instead of actually going about dividing, we're going to multiply by the reciprocal of whatever fraction we're trying to divide by. We'll do a whole bunch of examples to show this, but right now let's write this down. Division of fractions is the same thing as the multiplication by the reciprocal of the second fraction. One more thing I need you to notice from this example. Did I do anything to the 6? Did the 6 change at all? No, 6 didn't change. It's just the second number that I'm reciprocating. So division is equivalent or is the same as multiplication by the reciprocal of the second fraction. Division is the same as multiplication by the reciprocal of the second fraction. In other words, here's what I'm saying. Take a look at the board with me real quick. Let's use some general letters. So if I had some fraction divided by some other fraction, A over B divided by C over D. Listen, we really don't have a way to go about and divide fractions easily without this. We don't have a way. What we're understanding is that division and multiplication by a reciprocal are the same thing, and that's what we use for division. We can't just look at two fractions and go, oh, what's this one divided by this one? It doesn't really work, at least not easily. We want something that works all the time that's not too complicated, right? Right? Yeah, of course. So what we do is, instead of going straight for the division, we kind of flank the problem. We go, okay, we're going to go around the division. We're going to take the division out of my expression. And by how we do that is we say, I know for a fact that division is the same thing as multiplication by the reciprocal of the second fraction. So first question, am I going to be flipping over my AB?
No.
Did I flip over the 6? No, I'm going to leave that one alone. Am I still going to have division? Am I still going to have division here?
No.
No, what am I going to have instead? Yeah, which is nice because we just learned multiplication, right? That's great. Now, the second fraction, that's the one we need to reciprocate. So instead of C over D, what am I going to write over here? Ladies and gentlemen, these are equivalent statements. In fact, we just did this up here. Division by a number, the same thing as multiplication by the reciprocal of that number. It'll give us the same exact answer out of that. This is the way we get around our division. We change our division to a multiplication by the reciprocal. Everything will work out just fine. So really, all I'm teaching you today is how to flip a fraction. That's really it. Because as soon as we do this, do you guys see we have multiplication back again, right? We just did multiplication. So we're going to have the same set of rules, the same ideas, only we're flipping the second fraction. Raise your hand if you feel all right with this so far. Okay, good. Let's go ahead and try some examples, flesh this idea out a little bit, and then we'll continue.
Would it would be solved if it was in division or no? I don't know.
Say what now?
Like, I know it's easier to flip that way, but can you still do it in division? Or I didn't hear if you said anything about that.
No, geez, I don't know a good way. No.
Okay, that's what I was just wondering if it's still possible to do it that way.
Probably by manipulating the fractions a little bit more, yeah. But it's not going to be easy, no.
Yeah, that's what I was.
Okay, let's start off nice and basic. Just do some nice simple fractions here to get the hang of this thing. So we clearly have a division problem. Now, we can't go ahead and conquer division directly. We go around the problem and we change it into something that we can accomplish. How we change division is we change it into multiplication. But the only way we can do that is by reciprocating, which one, the first, the second, or both fractions?
Second.
Just the second one. So when we're doing this problem, we go, all right, we got 3/4 divided by 1/8. Instead of 3/4 divided by 1/8, we're going to write that as 3/4 stays the same. The division, though, we're going to change it to multiplication. And the way we change the multiplication is reciprocate the second fraction. What's my second fraction have to be? Hey, we've seen stuff like that before, right? That's multiplication. How do we do multiplication? Straight lines, straight across, draw the line, put the dot dot, or rewrite this as one fraction, which is what I'll do. Nice, and then we just simplify. So really, it's just one extra step. It's this step right here. It's doing the reciprocal, and then you're dealt with a multiplication problem again, and we can accomplish this just like we normally did. So let's try to simplify it. Do you see any numbers that can simplify, ladies and gentlemen?
4 and 8.
Great. We'll cross the 4 out and put a what?
1.
And the 8 out and put a...
2.
Good, because 4 divides both those numbers. And we'll keep on going. What are we going to have here?
6 over 1.
Okay, 6.
Equals 6.
Good. So we're going to get just a 6. 6 over 1, we're just going to write 6 on that. Let's try it. One more together. I'll give you a couple do on your own, and we'll move on. Okay, 5/16 divided by 3/4. Why don't you tell me the first thing I'm going to do?
Put it into change it to multiplication.
Good. Now, there's one thing I do want to show you here. The reason why, one of the reasons, among the several, that I have you write things as one fraction before you simplify, take a look at this real quick, please. The one reason why I have you do this before you simplify is if I let people cross out the 8 and the 4 right now, when they get down to division, a lot of times people make the mistake and do this. I'm going to change the problem just briefly for a second, okay? Let's say that this was something like 12. Let's say that was 12. Could I cross the 12 out with the 16?
Yeah.
That's the reason why I have you do this, is because you cannot do that. Okay, you can't do that on division. You can't go ahead and just go, oh, yay, 4 goes into this 3 times, 4 goes into this 4 times. It doesn't happen. Why? Because look what you're going to do. you're actually going to flip this thing over, right? That 12 is no longer on the numerator anymore, now it's on the denominator, and then you cannot cross those numbers out. Raise your hand if you saw that. You understood that. Okay, so we can't cross out unless we make one fraction. We can't make one fraction unless we're multiplying. So, can you simplify directly from division? Shake your head and go, no. Can you simplify directly from division? Absolutely not. No. Just multiplication. That's why I have you do one fraction. Is it starting to make sense now why I have you do that? Okay, that way, because I'm saving you from making a mistake here. Okay, let me rewrite. What did I give you? 5/16
divided by 3/4.
Good. So the very first thing, before any simplification, before any of that, the only thing that we, what now? Yeah, the only thing that we can do here is do our multiplication. So we're going to leave our 5/16 alone. That doesn't ever reciprocate. We're only looking at the second fraction. We'll flip our second fraction and do 4/3. And by reciprocating a fraction, we're changing our division into multiplication. Now's the point where we make one fraction. Now's the point where we get to simplify. We'll have our 5 times 4. We'll have our 16 times 3. You can just extend the line if you'd like. That's fine. Just make sure you're only doing that with multiplication. And now we get to simplify. What do we simplify here?
4 and 16.
Good. On the top, we get a 1. Bottom, we get a 4. Is there anything else, ladies and gentlemen?
No.
So I'm going to have 5 times 1. I'm going to have 4 times 3. You can't simplify that. You're done. Why don't you try a couple on your own? Okay, first one. So we know that division, same thing as multiplication by the reciprocal. So the first thing I'm hoping that you did, do you flip the 8/7?
No.
Do you reciprocate the 2/9?
Yes.
And instead of division, now we have multiplication. We'll extend our line, or you'll rewrite the fraction as 8 times 9 over 7 times 2. We'll try to simplify what we can. Do you see anything?
2 and 8.
2 goes into 2 one time, into 8 4 times, so our answer, we should have 36 over 7. Do I need to simplify it anymore? No, that is actually simplified. If I asked for a mixed number, I'd be asking for a mixed number, which isn't the same thing. So simplification, that's done. That's good. If I asked for a mixed number, then you'd go ahead and write 5 and 1/7. Okay, you could do that, that's fine, but unless I specifically ask for it, or the problem gives it to you as a mixed number, you don't have to do that. Okay, next up, last one. First question I have for you. Is it okay to simplify the 2 with the 4 right here?
Yeah.
Is that ever okay with division? No, we can't. The only time we can do that is if we can make one fraction out of it, and that only happens with multiplication. So here we'll flip our second fraction, we get 4/9. We'll get 2 over 1. Actually, nothing even simplifies there. We're just going to get 8/9, and we're done. As good as we can do. How many people feel pretty good about these two examples? All right. Hey, what do you think our answer is going to be? Positive or negative? What do you think?
Negative.
Why negative?
The negative times the negative.
Because you're
times
dividing.
positive is a negative.
Yeah, you're dividing. That's right. Same rules as multiplication. So if we have those different signs, we're going to get a negative out of this. And that's really the key to doing multiplication and division, is figuring out, fractions at least, is figuring out the sign of this fraction before we even start. So right now, I know for sure that my answer is going to end up being negative. And we're going to see that because division changes into multiplication. We're still going to have a negative times a positive. That's going to give us a negative. So in the first part of this, we'll leave our first fraction alone. We'll multiply by the reciprocal of our second fraction. We know that a negative times a positive is a negative. That means we're going to have a negative 10 times 9 over 4 times 2. Are you still with me?
Yeah.
Okay. And then we're going to simplify. What can we simplify?
10 and 2.
10 and 2, okay. 10 and 2, they'll share a factor of 2. So we'll divide both of them by 2. 2 divided by 2 gives us how much?
1.
10 divided by 2 gives us? What's our answer going to be?
45.
45 fourths?
Negative 45.
Negative 45. Okay, that works. I want you to notice one more thing about this problem. Do you see the first two fractions that we had on the board? The negative 10 fourths? Can you reduce negative 10 fourths?
Yes.
Yeah, you actually could, right? 10 fourths is the same thing as 5 halves. You can always simplify your fraction before you even begin. If you were to do this problem, you actually wouldn't have any simplification here. I want you to see that you get the same thing. I'll do this once. You don't have to write it down unless you really want to, but check it out. Negative 10 fourths, if you divide both by 2, you're going to get negative 5 halves. You can do the same thing we've been doing, right? Divide both by 2. You get negative 5 halves times 9 halves. You're going to get 45 fourths, negative 45 fourths. Same exact thing. So if you want to save yourself some time occasionally, see if you can simplify your fractions before you even start. Nod your head if you're still okay on that. Okay, we'll do one more with just some numbers. We'll throw some variables up there, and then we'll do some evaluation. Let's do this thing. So negative 7/12 divided by negative 5/6. Ladies and gentlemen, our answer is going to be positive or negative. What do you think?
Positive.
For sure. Negative divided by negative is for sure positive. So you know what we can do, now that we've determined it's going to be positive, we don't have to write any signs anymore. We know for sure that this thing is going to be the same as 7/12 times 6/5. Where did the negatives go?
Wait,
Why?
because the negative times negative
Yeah,
makes
you know it's going to be positive, so we're good. We know our answer is going to be positive. We've already reciprocated. We flipped over that second fraction. We're going to extend our line. We're going to put the dots, signifying that we're multiplying. We can do that because we are multiplying two fractions. What simplifies here, ladies and gentlemen? What goes into both those numbers? So our answer? And it's positive. Exactly right. Can we do the same thing if we have some variables? We're going to take a look at that right now. All right, 3y over 4 divided by 5y cubed. Thinking, wait a second, we don't even have a fraction. Oh, there is. So I can change anything into a fraction if I want to. So if I have 5y over 3, or if 5y to the third, we'll just put this over 1. And get yourself a built-in fraction. Tell me my next step somewhere on the left-hand side of the room. What are we going to do? Okay. Reciprocal, the first, second, or both?
Second.
So I'll take my 3y over 4. The reciprocal, what's the reciprocal of 5y cubed? What's that
1 over
reciprocal?
5 YT.
Okay. Yeah, we're for sure multiplying. And now we're ready to write this thing as one fraction since we're multiplying. We just write the numerators on one numerator. We write the denominators on one denominator. And we look to see if we can simplify this. Do you see any common factors on the top and bottom?
Y's.
The y's, that's right. And I showed you a method to do this. If you're good at the exponents, thinking about y over y to the third and understanding that this is really y to the first power right there, and we're taking one of those away from these 3 y's, there's going to be 2 of them left. Are you with me on that one?
Yeah.
2 of them left. Or, if that doesn't really flow with you, think about it 3 times y times 1. Think about it as 4 times 5 times y to the third means y times y times y. That's y to the third. How many y's can I cross out?
1.
And then you're still going to get 3. Here you're going to get your 20. And here you have, what's left?
Y squared.
Yeah. You get the 20y squared. Folks, would you raise your hand if that one made sense to you? All right. All right. Try one of these things on your own. Let's do 2x over 3. Divided by 3x squared. All right, so let's handle this problem. So we're going to make this into a fraction first. Just put that thing over 1. Of course, division means we've got to multiply by the reciprocal of the second fraction. So instead of 2x over 3 divided by 3x squared, we're going to have 2x over 3. That one doesn't change, but now we're going to multiply by 1 over 3x squared. We take our reciprocal of that. We'll make this into one fraction. You can choose to write this again or simply extend that line. And we look to see if there's anything that will simplify. Do you see anything that will simplify?
X.
No, the x's.
Those x's, you've got to do that. So we're going to have 2x, or 2 times x, times 1, over 3 times x times x. X squared gives us that x times x. So every time you see that, that's what we're doing. We cross out our x's here. There's only one pair that match up on our numerator and denominator. That's the common factor there. What's our new numerator?
2.
Good.
2 over 9x.
9x, good, because we're multiplying what's left over. We have 3 times 3 is 9. We still have one of those x's. That should mean x to the first power or x. Raise your hand if you got that one. Good for you. That's fantastic. Can you do that problem?
Yes.
Do you need to flip anything over? Do you need to reciprocate any fractions?
Yeah.
No, it's multiplication.
Oh, okay. So don't get confused between division and multiplication. If I'm not giving you division, don't automatically assume you're going to flip stuff over. You with me on this? Okay. You can do this one.
Is multiplication, you don't put it over or what?
Did we when we do this multiplication, do you flip this one back over?
No.
Now, if you can do that, can you do that?
Yeah.
Okay. What are you going to do first?
Parentheses.
Sure, this is order of operations. So let's multiply those fractions together. Let's get one fraction out of it, and then let's divide by the 7/15. So let's try that. So to multiply these fractions, are we going to get a positive or negative here, ladies and gentlemen? So we're going to have, I know it's negative 2 times 9 over 3 times 14. And then after that, I'll be dividing by 7/15 after that. Hey, does anything simplify?
Yes.
Yeah, I see a 3 and a 9. Okay. Let's divide both a 3 and a 9 by what number?
3.
So we're dividing by 3. 3 divided by 3 is 1. 9 divided by 3 is?
And the 2 and the 14.
Good. 2 goes into both those numbers. 2 goes into 2 1 time. 2 goes into 14 7 times. Let's rewrite our fraction, and then let's divide by 7/15. I still have a negative
3, 7.
divided by a 7/15. Okay, nod your head real quick if you're okay with this. Hey, it's very tempting to cross the 7s out. Can you do it?
No.
No, you gotta
Reciprocate.
Okay, so we can't cross anything out until we have that multiplication. So now we have basically a new problem. It's like 2 problems in 1. We've got the multiplication. We already did that. That was negative 3/7 from here. Now we have a negative divided by a positive. I know right in my head that that's going to be a negative. I know that I'm going to keep that negative 3/7. I'm going to be multiplying it, but instead of 7/15, I'm going to have 15 over 7. Yes, no? We extend our line, signifying that we're actually multiplying, and then we look for anything we can simplify. Can we simplify anything on this problem? No, the 3 and 15 are on the numerators now. We can't cross that stuff out. 7 and 7 on the denominators. We can't cross that stuff out. All we're left with is multiply what's left over. I know we're going to get a negative. Our numerator is going to be 45. Our denominator is going to be... That's as good as you can do. You can't simplify that anymore. Try one of these on your own. Let's do 4/7. 3/8. Divided by negative 3/4. Okay, so kind of an order of operations problem and a fraction problem all tied together. And we're going to have some of those later in this chapter as well, where we put a lot of stuff. Addition, subtraction, multiplication, division, exponents, all together in these problems. So this is kind of a nice stepping stone for us. Now, the first thing that it says to do is look for any parentheses, do what's inside of them. Now this parenthesis just says I have a negative fraction, but this one says I can do something in there. Of course, when we have multiplication, I want to see one fraction before you start crossing stuff out. Make sure you know you can do that, because I would hate for you to start simplifying across division by mistake. Here we do have some things we can simplify. We've got a factor of 4. But nothing else. We've got a 3 and a 7. So we'll do the rest of our fraction by multiplication. We'll get 3 over 14 divided by negative 3 over 4. Raise your hand if you made it that far. Good deal. Now, question here, is our answer going to be positive or negative? What do you think?
Negative.
Good. So you really can choose to do one of two things. You can choose to keep this negative with the number if you'd like, Or you can choose to understand that a positive times a negative gives you a negative, move the negative up front. You know your answer is going to be negative. You can do that. Now I'm going to keep it with the negative 3 because I saw a lot of people did that on their paper. That's fine. That's okay. So if I'm dividing 3/14 divided by negative 3 over 4, I'm not going to flip the first fraction. I'm not going to be even dividing anymore. I'll be multiplying, but I'll be doing that by the reciprocal of the second. Are you okay with that? Now, when you extend the line here, and you put your multiplication, notice that I'm not subtracting. I'm multiplying by that negative 3. To show that, if you like, put that parentheses, that way you know you're not subtracting 3. I don't want you to give me something like 11 here. That'd just be a silly mistake. That'd be bad. But we don't do that. We're multiplying. So you're multiplying by negative 3. Let's see if we can simplify any of these numbers and see if it works out to be a negative like we know it should be. What factors do we have up here?
3 and 3.
Okay, so 3 and 3 share a factor 3 and negative 3 share a factor 3. You just have to divide correctly with the sign. If we divide 3 by 3, how much are we going to get?
1.
If we divide negative 3 by 3, how much are we going to get?
-1.
So as long as you don't forget about that negative, you'll be fine. So we're multiplying by negative 1 there. Lastly, we've got 4 and 14. I know those share a factor of 2. So we're dividing 4 by 2. We're dividing 14 by 2. We're going to have 2 over I got 2 over negative 7. Is that correct?
Yeah.
Listen, with fractions,
Could it be negative 2 over 7?
just get into that. With fractions, it doesn't matter where the negative is. So here's what I'm trying to tell you. You need to watch this up on the board here real quick. Because a lot of people, they're under the misconception that this is different than negative 2/7. They're the same thing. This, watch on the board, is the same thing as this. And it's the same thing as this. All those have the equivalent expression. Positive divided by negative, or negative divided by positive, or negative positive divided by positive is the same expression. So wherever you put that negative, it doesn't matter, as long as you only have one. How many people are with me on this stuff so far? We're going to talk about evaluation for just a couple minutes, and we'll call it a day. What's evaluation mean? We've had that word a lot in this class. What does it mean when I say evaluate something?
Plug in.
Plug in, that's key, and then work it out. Give me a number. Give me an answer to that. So we're going to try to evaluate using some of this fractions ideas. I'm asking you to do two parts here. I'm asking you to find xy. What's xy mean? Okay. I'm asking for x divided by y, so we're dividing. Using the same values. X is negative 3/4 and y is 9/2. Let's try to set these up first, and then we'll have you guys solve them. So first, the setup. Let's do xy first. What do I need to write for xy? This one. Negative, okay, negative 3/4, and then what?
Divide by 9.
We're dividing there?
No time.
Timesing. Okay, how do you know it's times? How do you know it's multiplication?
We run next to each other.
Yeah, that's what that means. We have xy right there. That means x times y. So x was negative 3/4. Y is 9/2. Can you do that?
Yeah.
Great, we can do that one. Let's set up the next one. We have x divided by y. Of course, x is still the same. Negative 3/4. Only this time we're dividing by 9/2. Hey, do you think we're getting the same answer here and here?
No.
Two completely different ones. Work them out, see what you get. Okay, so the first one. Ladies and gentlemen, do we need to flip anything or reciprocate anything on the first fractions here, first problem? No, it's multiplication. Don't change any of that stuff. All we're going to do is extend our line or rewrite the fraction as I'm about to do. We'll look for anything to cross out. Is there anything to cross out there?
No.
Any common factors that you see?
No.
No. So we're going to get negative 27 over 8. Raise your hand if you got negative 27 over 8. Cool, all right. Next one, we have a division problem. Division says you are going to find the reciprocal at some point. We'll have negative 3/4 multiplied by 2/9. Again, we'll have to write this as one fraction because basically this changes a division problem into a multiplication problem, and we start all over again. Negative 3 times 2 over 4 times 9. I know my answer is going to be negative, so you can choose to do one of two things. Either move the negative out front like I did here. Move that negative out front and don't worry about it. Or if you're going to divide by 3, make sure you have a negative 1 up on the top so you don't lose that negative. Nod your head if you're with me on that. Okay, so here we'll go, okay, 3 goes into both negative 3, negative 1 times, 3 times. 2 goes into both 2 and 4, 1 time, 2 times. Can you tell me my answer out of this?
Negative 1/6.
As long as you got that negative, you'll be right. Last thing we got to talk about today, do you remember how to tell if something's a solution or not? Okay, so we do plug it in and we see if it's equal. So what we do here is, if I'm asking is negative 9/8 a solution to this problem, we're taking our negative 9/8, substituting in for our variable, and we're seeing if these things are in fact equal. So in our case, we'll have, what's a 2x mean, by the way? Good, so 2 times negative 9/8. I'm going to put a little question mark here saying, oh, we don't know if that's equal yet, we got to do some work on it. How do I do 2 times negative 9/8?
That's only one.
Okay, so I got to change it to a fraction first. Is our answer over here going to be positive or negative?
Negative.
Good. So I'll have negative 2 times 9 over 1 times 8. And we're asking, is that the same as negative 9/4? What do you think?
Yes.
Yeah, we'll do some simplification. 2 goes into 2 1 time and into 8 4 times. We get negative 9/4. That is equal to negative 9/4. Is that a solution or not?
Yes.
Good. So we're done. Would you raise your hand if you understood what we talked about today? Feel pretty good about this stuff. Good deal.